What if I told you there's a jet engine so powerful that when 4 of them ignite at full throttle, the shockwave rattles windows a mile away? That the aircraft it pushes can outrun a rifle bullet, and there is nothing on Earth fast enough to chase it down? Today, we're counting down 50 of the most powerful jet engines ever built. Before we dive in, what do we mean by most powerful engine? We're talking raw thrust, the force measured in pounds that rips a multi-ton aircraft off the ground and flings it past the sound barrier like it's nothing. More thrust means more speed, more altitude, and more lethality. So buckle up and let's start with the Rolls-Royce Welland, the engine that started it all for the Allied powers. The Welland was Britain's first operational turbojet, and it powered the Gloucester Meteor, the only Allied jet fighter to see combat in World War II. By modern standards, 1,700 pounds of thrust is almost nothing. But in 1944, it was revolutionary. Next is Junkers Jumo 004. Germany got there first. The Jumo 004 was the world's first production turbojet engine. It was underpowered, unreliable, and dangerous to fly. If Germany produced it a year earlier, the air war over Europe might have looked very different. BMW 003. Another World War II German entry, the BMW 003 powered the Heinkel HE-162 Volksjäger, a fighter Germany designed and built in just 69 days out of desperation. It was fast to build and fast to crash. The BMW 003 was imperfect and dangerous, but its legacy shaped jet engine design for decades. Next is de Havilland Goblin. The first engine to crack 3,000 pounds of thrust, the Goblin powered the Vampire, Britain's sleek, twin-boom jet fighter. It was also the first jet engine to complete a transatlantic flight. Allison J-33. The J-33 powered America's first operational jet fighter. Not a combat legend, but a crucial stepping stone. Rolls-Royce Nene. The Nene was one of the most powerful jet engines of the late 1940s. And here's the twist. Britain sold the technology to the Soviet Union in 1946. The Soviets reverse-engineered it into the Klimov VK-1, which powered the MiG-15. Next is General Electric J-47. Over 35,000 J-47s were built, the most produced American jet engine of its time. It powered the B-47, America's first swept-wing jet bomber. Rolls-Royce Avon, the Britain's workhorse. The Avon powered the English Electric Lightning, the only British fighter ever capable of intercepting Soviet bombers at altitude. Snecma ATAR-9C, France's defining engine of the Cold War. The ATAR-9C powered the Mirage 3, arguably the most exported fighter design of its era. Israel, Argentina, South Africa, Australia, everyone wanted a Mirage at its time. Rolls-Royce Orpheus. Small engine, but extraordinary story. The Orpheus powered the Gnat, a tiny, nimble fighter that India turned into a frontline combat jet. During the 1971 Indo-Pakistani War, Indian Gnats repeatedly outmaneuvered Pakistani F-86 Sabres and claimed aerial victories. Next is Adore Mark 951. The Adore is known for two things: powering the Red Arrow's display team and serving as the frontline jet trainer for dozens of air forces worldwide. If you've seen the Hawk, you've heard the Adore. It's the quiet backbone of military flight training across 4 continents. Klimov RD-33. Twin RD-33s make the MiG-29 one of the most agile fighters ever built. The Fulcrum's famous airshow maneuvers, tail slides, flat spins, cobra pulls, are a direct result of this engine's raw power reserve. When the MiG-29 first appeared at Farnborough in 1988, Western pilots stood in silence. Volvo RM-12. Sweden's smart answer to the Cold War. The RM-12 powers the Gripen, a multi-role fighter that costs a fraction of an F-35 and competes with it in nearly every performance category. The RM-12 proves you don't always need the biggest budget to build something exceptional. Next is Snecma M88-2, France's modern crown jewel. The M88-2 powers the Rafale, a fighter that's won export deals across India. But it is sad reality that Indian worst pilot Make It a Shame and destroyed its name in many wars with Pakistan. Eurojet EJ200, one extraordinary engine by 4 nations. The EJ200 powers the Eurofighter Typhoon, and its thrust-to-weight ratio is so high the Typhoon can accelerate going straight up. NATO pilots who've flown it describe it as feeling like the aircraft is on a rail, pointed anywhere you want, immediately. That kind of responsiveness starts with this engine. Next is Pratt & Whitney J52. No afterburner, no glamour, just an engine that showed up to work. from Vietnam through the Gulf War without complaint. The A-6 Intruder flew more carrier-based strike missions than any other naval aircraft of its era, in all weather, day or night. Pratt & Whitney TF-33. The TF-33 powers the B-52H, a bomber that first flew in 1955 and is currently expected to remain in service until 2050. One engine family, nearly a century of service. That's not just impressive engineering, that's a generational commitment that no other aircraft program on Earth has matched. Rolls-Royce Spey. The British Phantom used the Spey instead of the American J-79, and in certain conditions, it was actually faster at low altitude. Interestingly, the wider intakes needed for the Spey compromised the Phantom's top speed up high. Next is General Electric J-85. The J-85 is tiny and brutally small, but it powers the T-38, the world's first supersonic trainer, which NASA still uses to keep astronauts sharp between shuttle missions. Snecma ATAR-9 K50. The 9K50 lived a hard life. It powered the Mirage F1 through combat over Chad, Libya, Iraq, and Kuwait. This engine went to war more times than most pilots. Pratt & Whitney J57. The J57 powered America's first supersonic fighter, its early strategic bombers, and its legendary spy plane, all at the same time. General Electric J79. This is where it starts to get serious. The J79 powered the F-104 Starfighter, a jet so fast and so unforgiving that pilots gave it a nickname, the Widowmaker. It also powered the F-4 Phantom, the backbone of American air power through Vietnam. Pratt & Whitney J75. The J75 pulled the F-105 Thunderchief through more Vietnam combat missions than any other aircraft. It also pushed the U-2 to 70,000 feet, high enough to photograph Soviet missile sites in complete secrecy. Kuznetsov NK-12. Technically a turboprop, but its power is jaw-dropping. The NK-12's contra-rotating propellers produce a shriek so loud that NATO submarines reportedly detect the Tu-95 Bear underwater through the hull of their vessels. A bomber so loud it gives away its own position. And it's been flying since 1956, and still flying today, showing its legacy. Next is Pratt & Whitney TF-30. The TF-30 and the F-14, a Tomcat had what diplomats would call a complicated relationship. At high angles of attack, the very maneuvers dogfighting demands, the engines would sometimes experience compressor stall and simply stop. Tomcat pilots had a more colourful way of describing it. The later F-110 powered F-14D fixed the problem, but the TF-30 era gave those pilots some stories worth telling. Next is Saturn AL-31F. The AL-31F is the engine behind the Flanker family, Russia's definitive air superiority platform, Pugachev's Cobra. Where the nose pitches up to 120 degrees while the aircraft keeps flying, is a maneuver no Western fighter can replicate. General Electric F-110-GE-129. In the 1980s, the Air Force was frustrated with Pratt & Whitney's monopoly on the F-16's engine, so they invited General Electric into the competition. The result was the Great Engine War, and both companies made better engines because of it. Pratt & Whitney F-100 PW232. The F-100 has been powering America's most important fighters for over 50 years. The -232 variant pushed it to its most powerful configuration. General Electric F-110-GE-132. The most powerful F-110 variant ever built. It packs more thrust than dedicated interceptors from the Cold War era. Aviation D-30F6. The MiG-31 Foxhound was designed for one specific purpose: chase down and destroy the SR-71 Blackbird. The D-30F6 gave it the thrust to reach Mach 2.83, faster than almost any other combat aircraft in history. General Electric F-101. 4 F-101s power the B-1B Lancer, a supersonic strategic bomber that can go supersonic at low altitude. Next is General Electric F-404 family. The F-404 is the definition of quietly excellent. It powers the F/A-18 Hornet, the carrier jet that's fought in every American naval conflict since the 1980s. Some of history's most respected engines don't make headlines, they just get the job done, year after year. Saturn AL-41F1S. Thrust vectoring taken to its extreme. The AL-41F1S gives the Su-35 the ability to redirect exhaust in virtually any direction, letting the aircraft point its nose and its weapons before the aircraft's body has finished turning. Western pilots who face simulated Su-35s in exercises describe it as fighting a jet that doesn't follow the same physics they do. That's not an exaggeration. That's the AL-41F1S doing its job. General Electric F118. The F118 has no afterburner. That's completely intentional. An afterburner creates a glowing exhaust plume visible on infrared sensors from miles away, which is the last thing you want on the world's most sophisticated stealth bomber. The B-2 Spirit is invisible to radar. The F118 keeps it invisible to heat sensors too. Next is AVIC WS-10 Taihang, the most advanced variants. China spent decades dependent on Russian engines. The WS-10 changed that. China's indigenous turbofan now powers its frontline fighters and continues to evolve with each variant. Rolls-Royce SNE-CMA, Olympus 593. 4 Olympus 593s pushed 100 passengers across the Atlantic in under 3.5 hours at Mach 2.02. At that speed, friction heated the airframe so intensely that the aircraft physically stretched by 10 inches. The aluminum airframe would literally expand and contract with the temperature. General Electric J93. 6 J93 engines drove the XB-70 Valkyrie to Mach 3 and 74,000 feet. The Valkyrie was America's answer to a world where bombers needed to outrun missiles. Literally fly faster than the interceptors and surface-to-air missiles sent to destroy them. Saturn AL-41F1 for Su-57. Russia's 5th-generation stealth fighter runs on the AL-41F1, a next-generation turbofan with full 3-dimensional thrust vectoring and supercruise capability. Supercruise means sustained supersonic flight without lighting the afterburner. Pratt & Whitney F135, the most powerful fighter engine ever built in the Western world. The F135 powers all 3 variants of the F-35, the conventional Air Force model, the carrier-based Navy model, and the short takeoff and vertical landing Marine Corps model. The engineering complexity is almost incomprehensible. 1 engine and 3 fundamentally different aircraft. Next is AVIC WS-15. China keeps the WS-15 tightly classified. Official specifications are sparse, but what's known is the WS-15 was designed specifically to give the J-20 stealth fighter supercruise capability and performance parity with the F-135. Its development took decades. Its existence signals that China's air power ambitions are no longer aspirational, they're operational. General Electric GE 90-115B. Yes, this is a civilian engine, but the numbers are too staggering to overlook. The GE 90-115B is the most powerful jet engine ever certified for commercial flight. 115,000 pounds of thrust and no afterburner. Pratt & Whitney F119-PW-100. On paper, 35,000 pounds of thrust is less than the F135, but the F119's defining achievement isn't maximum thrust with the burner lit. It's what it can do without it. The F119 gives the F-22 Raptor supercruise, sustained Mach 1.5 flight in clean configuration with no afterburner. That means the F-22 arrives at supersonic speed before most enemy fighters have finished reacting. Kuznetsov NK-25. 2 NK-25 engines. That's over 110,000 pounds of combined thrust in a single supersonic strike bomber. The Tu-22M backfire was designed with one primary mission: sink NATO aircraft carriers. Its speed, range, and weapons payload made it one of the most feared Soviet aircraft of the Cold War. NATO took the threats so seriously, they built entire carrier defense doctrines specifically around stopping the backfire from getting within missile range. Pratt & Whitney J58. The numbers seem modest at this point. Don't let them fool you. The J58 is unlike any other engine on this list. It's a hybrid, part turbojet and part ramjet. At low speeds, it operates as a conventional turbojet, but above Mach 2.5, it begins bypassing the compressor entirely. It ran so hot that conventional jet fuel would vaporize before it could combust. So engineers developed a special fuel, JP7, so stable that it required a chemical ignition agent just to light it. Next is Saturn A L51F, the next-generation Russian engine. Russia's next-generation power plant is currently in development and testing. Designed to replace the AL-41F1, on the Su-57. Estimated thrust figures are classified, but reports suggest it will significantly exceed its predecessor. Next is Kuznetsov NK-321. The NK-321 is the upgraded successor to the most powerful military jet engine ever built, and it's still being produced today. Kuznetsov NK-32 produced 55,115 pounds of thrust. The Tupolev Tu-160 is the largest combat aircraft ever built, the heaviest and, still, the fastest bomber in the world. 4 NK-32 engines give it a combined thrust of over 220,000 pounds. To put that in perspective, that's greater than the total thrust of a NASA space shuttle at liftoff. That's all for today. Now, if you like this video, make sure to hit the like button and do subscribe to our channel. And tell me in the comment below, what should be our next video?